Hi, everybody. As you've seen, we run a little bit behind. Hopefully, the people that wanted to see my show or the people that came for Leap Motion can wait a little. They come just after me. I'm working for Bosch Santa Clara, and today I want to talk about sensors for VR and AR. And when I say sensors, I specifically talk about motion sensors, not anything about optics or anything like that, but what detects the movement. But before I do that, just a little bit about Bosch Santa Clara, which is specifically the daughter company I work for. We're 100% Bosch. That's been created in 2005 by Bosch to focus on MEMS sensor for consumer electronic. And MEMS sensors means micro-electrico-mechanical systems. And I will spend a little bit more time just later, like a minute or two, on it to explain what that means. But we make sensors for everything that comes from smartphones, laptop, and obviously VR, AR type of applications. Just a very quick overview of the sensors at Bosch. Bosch Santa Clara is the bubble in the middle. You see on the left, you have the automotive sensors. Most likely, every one of you actually drive with some Bosch sensor in their car. And on the right side, you have the kind of extra layer on top of that. You take the sensors and you build system around it, all the IoT, Internet of Things type of application. So it's numerous. I don't want to spend much time on that. But in the middle, as you can see, beyond the motion sensors that you have in headsets and all this kind of things, you also have environmental sensors and a lot of very interesting things that may make their way into AR and VR headset later on. But I will not spend any time on that in this presentation. But first, why do you actually need sensors in a headset? It's actually an interesting question because for most people, what is a VR headset? It's a screen in front of you and they build images and you kind of see 3D and you have, as it says, virtual reality. The thing is, when you move your head around, the systems, if you didn't have sensors, had little ways to know that. And the previous speakers and so on talked about a lot of optical ways or different methods to know that you are moving around and detect the position of your body. But usually they have a lot of latency and maybe not the precision you need to be able to know exactly where your head is moving to. So every headset out there, being AR, VR, and all of that, have actually sensor in there. And for most part, they're actually Bosch sensors. If you take the time to open a few of them, you will see a nice little black thing that's actually has a Bosch logo on it. The idea is to be able to have the dynamic response to when you move your head to the right, the image moves fast enough. And I would spend a little bit more time later on, but that's actually not as simple as it sounds. There is also something else that kind of goes towards head tracking. Some of you may have heard about the Tango type of application. Maybe you heard the talk from the Lowe's Innovation Labs thing, where they use this to offer even more application. This also uses sensors along the camera systems to be able to do indoor localization and a lot of things. So sensors are everywhere and used for a lot of things. And even if they're used in there to track your head movement, they can actually maybe do more. They can maybe count the number of steps you make. So instead of just looking at where you're looking at, if you make a few steps, they're able to detect that and they make you move into an environment. So those are the main use cases. But not to forget, when you talk about VR, a lot of time you have to interact with your system. And today, for most applications, when you look at the Oculus Rift and all this or the PlayStation, they have something in your hands. And they use an accelerometer, a gyroscope, and a magnetometer to be able to know where you're pointing at and to show that in real time in the space you have. So sensors are really used in a lot of different spaces and do these kind of things. In most cases, it's really the accelerometer and the gyroscope that do the bulk of the work. And accelerometer being mostly the static orientation, the gyroscope giving you the dynamic rotation. But yeah, I will try to make that very brief. I can speak about 4 hours on just that part of the presentation, so I will just try to summarize that in a minute or two. What is a MEMS sensor? On the picture in the middle of the screen, you have actually one of our standalone accelerometers. This is a part that's 2 millimeter by 2 millimeter, and it measures acceleration along 3 axes. And inside there, you have an ASIC that does the electrical stuff and so on, but you also have a MEMS element. And this MEMS element, which I said before stands for macro electromechanical sensors, in a little bit less barbaric terms, it's really just a piece of silicon that's being etched, so that's been made to be able to move around. And so when you move one of these small devices, actually inside there's something moving around. And with a COM structure, you're able to measure the distance, so how the mass moves. And if you guys remember your high school class with, the force is equal the mass times the acceleration, we measure the force, we know the mass of the element, so we're able to calculate the acceleration based on that. And that's relatively as simple as that. There is a spring, something moving, we get acceleration out of it. The tricky part is how do you make that for the z-axis, for example, because you have something that's very flat and you want to measure there. So there's a lot of engineering. But the base system is really, we take silicium, and then we just punch it or make holes in it and so on to have something that moves. And that's really what you have on your head to detect the movement, or what you have in your pocket right now in your phone to detect all the movement on your phone and be able to turn the screen around. Now back to AR and VR. And specifically actually VR, because AR has even more challenges, but what are the main challenges you have today? When you take a VR headset, you put it on and you start looking at stuff. What are the main problems you have that are actually related to sensors? And one of the big ones is image drift. You put it on, take the example when you want to watch some kind of movie on your VR headset and you're sitting down and you're there for, I don't know, you watch for 30 minutes, an hour. If you have a bad sensor, what will happen is that you sit down there and the image will slowly drift. So you start by looking in this direction, and to keep looking at the right middle in the movie, you will have to slowly turn around, which is obviously a terrible experience because you notice that something is wrong and you have to change your focus. It's especially bad if you have an AR type of application where you want to overlay with a system, so you have a reference at the beginning, and then the overlays that you put on the image won't match with the real world because your sensors are telling you that you're actually turning when you're not. So that's one of the big problems. The other one, I put latency on there. That's actually a little bit more complex than that, but that's motion sickness. Motion sickness comes when more or less the image doesn't match with what your body is doing. There's a little bit more than latency, but latency plays a role into it. I don't know if you guys attended the talk from Jack Macaulay yesterday, where he worked at Oculus on some of these things. He spent a little bit more time talking about the MEMS sensors. But really, it's about making sure that how the image moves, it actually follows how your body moves. And that's lateral movement, that's about rotations, but you want to make sure that you make that happen fast enough and also with the right fidelity, otherwise people get sick. And I don't know if some of you tried the first version of the Oculus, there was a good way to get sick for a lot of people. Some are more sensitive than others, but yeah, you wanted to be sure you had a good stomach. Today, this technology got much better, partly because of better sensors, but also because the system integration really pays a lot more attention to that. Sorry. And what has been done to improve? When I talked about image drift, it translates into sensor output as an offset. If the sensor has a certain offset and then you integrate that over time, that's what will cause issues. Temperature also has a role into that. And the way to make this work correctly is actually to make sure that when you put the sensors into the board and into the headset, you put it in the right places where you don't create mechanical stress on the sensors, it's away from temperature sources and so on. You're really able then to build something that will have the least effect and the least performance hit. The other one, that's something we had a lot with a few manufacturers at the beginning. They were just not using the sensor correctly. Either the wrong filtering, no start calibration, a few different things, but that's purely on the design. If you guys want to know more, we can discuss on site. I will spend a lot more time to describe that than just one now. The last one is really about latency. Sensors are able to give data, real-time movement, really, really quickly. Actually, if you don't use filtering and so on, you are below 1 milliseconds of delay just from the movement and being able to have the data within a microcontroller and acting on it. The issue is that when you have a VR and AR type of applications, you want to do a lot more than just look at the data and say, I moved. You need to change something on the image by itself, so you have full bitmaps that you need to transfer. So you need to be able to push this sensor data right through to the DSP so that it can act and modify the image fast enough that you have time to send it to your image or your display, and that the user doesn't even notice any delay. So really, it's a full work, and at the beginning, I don't know if you guys are aware, but the first VR headsets were really using only phones, standard off-the-shelf phones, and trying to build something out of it. Problems is those were not built for that kind of use case, and that's why people were getting sick. At some point, they still use phones, but they changed the software pipeline in those phones to be able to do the VR correctly. And that's kind of what you see with Daydream, for example, when they take a Pixel phone from Google, they actually have a special pipeline just to be able to do VR correctly. So they use the same sensors. It's actually, the sensors in your phones are very similar, if not exactly the same, as the ones that you have in VR headset. It's just that the software pipeline that's behind it is different. And the real message I want to bring here is that it's not only about the sensors. You actually need to build a full system around the sensors to be able to do that. Sorry, I was trying to check the time. And so that's kind of what can be done. And today, what we have is some type of sensor. For example, from Bosch, there is a part, I will just throw the part number out there, BMI 055, which is very, very popular in the type of devices because it's very stable over temperature. It's a part that's really working really well for these applications. And that's a part you see in a lot of headsets, simply because it's very robust, and that's a very good sensor for these applications. One other thing you can do, and people do, is that when you put the headset on and when you start, you want to calibrate the no movement thing. That way you deal with, some of the issues you have. That's a very simple step on paper, but when it comes to do it on the machine, how do you detect a stand that you don't have a very slow movement and those kind of things? But that's things that have been done today. The last one is kind of an interesting point. You can do a lot with the sensors themselves, the MEMS sensors, but today we see a lot of approaches, and that's one, for example, WorldSense is what Google announced not so long ago, where you actually take a camera and you merge the output from the camera that looks at different points outside with the sensors. And that way you're able to actually mutually calibrate each other, and you really get the best movement and output for the sensor, and you can also do a lot of more interactions. So in short, it's kind of a similar thing as before, but the action here is like, if you really want to do a good VR, or even you apply, you use and develop apps for it, we all have to work together to make sure that this works well. And I know the sensors are at the bottom of the chain, but we need to do good sensors, and Bosch is working on that, but also what's on top of it needs to be done correctly. And that's really where everything comes together. So that was my talk, and yeah, so do you guys have any questions? Sorry? I'm saying we've gone over on time. I have 14 minutes right now. Any question? No, I guess not. Then thanks a lot, and I guess it's time for the next speaker.